In this video, I want to talk about conditional probability. Conditional probability measures the probability of an event, given that either by assumption, presumption, assertion, or evidence, another event has occurred. As an example, let's suppose that the probability that any given person has a cough on any given day is 5%. However, if we know or assume that a person has a cold, then they're much more likely to be coughing. The conditional probability of coughing given that you have a cold would probably be much higher. Conditional probability is denoted by this. This is the conditional probability of B given A. So this bar is read as given. A is the thing that we know happened, and B is the probability that we're trying to find. And this is given by the probability of A and B divided by the probability of A, provided that the probability of A is not 0. Let's do some examples. What's the probability of rolling a 4 on a die if we know that the number rolled is an even number? So I'm trying to find the probability of 4 given that it is even. So the second thing is the thing that we know something about. So this is the probability of A and B, so the probability that it's both a 4 and an even, divided by the probability of the thing we know, even. Well, on a dice, there's only one number that's both 4 and even out of 6 sides. And there are 3 sides that are even out of a total of 6 sides. So this is 1 over 6 times 6 over 3, or 1/3. So this probability would be 1/3. What's the probability that the sum of a pair of dice is 7, given that the first dice rolled was a 2? So I want to know the chance they add up to 7, given that the first one was a 2. Well, the rule says first the probability of both. Sum of 7 and we rolled the first one as a 2, divided by the thing that we know, the probability that the first dice is a 2. Well, if we think of the probability of rolling a 7 and the first dice being a 2, so we have 2 possible dice. We need the first one to be 2, and we need them to add up to be 7. So there's exactly one way we can do that out of a total of 36, since there are 36 possible ways to roll 2 dice. On the denominator, we're just talking about rolling the first dice, a 2, and that's 1/6. So we have 1 over 36 times 6 over 1, which is 1 over 6. There's a 1/6 chance that we roll a 7, given that the first dice rolled was a 2. What is the probability that the sum of a pair of dice is a 7, given that the first dice rolled was either a 2 or a 3? So once again, I want the sum to be 7. However, this time my first one is either a 2 or a 3. Well, we start with the probability of both. The probability we get a sum of 7 and the first one was either a 2 or a 3, divided by the thing we know. The first dice is either a 2 or a 3. Well, as I think through the first one, we are rolling 2 dice, so we know it's going to be out of 36. We know the first number could be a 2 or a 3. And we know it has to add to be 7. So it could be a 5 or a 4. So there are 2 possible things we could roll here. We could roll a 2 and a 5 or a 3 and a 4 to satisfy both of these conditions at once. The denominator is only looking at rolling 1 dice. There are 2 possible ways to get a 2 or a 3 out of 6. So we have 2 over 36 times 6 over 2, which reduces to 1/6. Next, I want to look at finding probabilities using what's known as a two-way table. So this came from a recent survey that asked 100 people a question. We broke it down to whether they answered yes or no to this question and whether they were male or female. So before we talk about conditional probability, let's look at some other probabilities on this table. Let's start with the probability that we selected someone at random and they said yes. Well, there was 100 people in this survey, and you can verify that by adding all 4 of these numbers. And we can see that 40 of them said yes, so 40 out of 100. Now let's look at the probability that we selected someone at random, and they said yes, given that they were a female. So we know that they were a female. So we know we are considering these people right here. And so with a table, we don't have to use our formulas for conditional probability. Instead, the fact that I know they were female means I'm going to ignore everything in the table but this one row. The chance they said yes was 80 out of a total of 50 females, so 8 out of 50. As another one, let's suppose we selected someone at random. I want to find the probability that they were male, given that they said no. So the thing that I'm aware of, the thing that I'm already know, is that the fact that this person said no. So I'm only considering this column right here. So what's the chance they were male? Well, there's 18 males out of a total of 60 people who said no. So 18 out of 60.